Okay, advanced math. One last topic with proportional relationships. Spent a lot of time kind of getting all the parts to these together. And I want to show you one last way today to represent them, and that is equations. We're going to write equations for them. So please go ahead and write this as the last proportional relationships title in your math notebook. When you're all done, close it up. You're going to remember, just think and concentrate with me on the I do's, and then you're going to write the we do's down. All right, so here's a real quick proportional relationship we've looked at before. It relates heartbeats and seconds, right? So we've looked at, kind of represented this in three ways before today. Verbally, just in words, there are 3 heartbeats every 2 seconds. 3 heartbeats, 2 seconds, 3 heartbeats, 2 seconds. We've represented it with a table, 0 seconds, 0 heartbeats, 2 seconds, 3 heartbeats, 4 seconds, 6 heartbeats, and so on. And we've represented it with a graph that looks like this, and we've learned how to tell the unit rate right there, and the constant of proportionality, and 0, 0, and all that good stuff, those 3 ways. So I want to expand that just a touch today and add one more representation to it. So here's the exact same relationship, and I want to add this equation representation today too. A proportional relationship can be represented with a simple equation. So if I look at this, there are 3 heartbeats every 2 seconds, or the table, or the graph. My favorite way to be able to write this equation is from the table. Because what happens is, if you'll remember how to find the constant of proportionality, you do that by taking the y divided by the x of any of these. They're all going to be the same. We can already tell this is proportional. So if I take any of these except for this one, I'm going to get the constant of proportionality. So I'm going to take the y as 3 and the x is 2. And so that's my constant of proportionality right there, 3/2 or 1 1/2. Another thing you can do with this is the constant of proportionality shows you this. If you look at the chart, if you ever take the x value and multiply it by that, you'll get the y value. 2 times 3/2 is 3. 2 times 3 is 6. 1 times 2 is 2, so you get 6/2, which is 3. Let me back up a little. 4 times 3/2 is 6. 6 times 3/2 is 9. So I can take that constant of proportionality, multiply the x by it, the time by it, and I'll get the y value. It actually even works here. 0 times 3/2 is 0. So what I can tell here is anywhere in this equation, if I take the x and I multiply it by 3/2, I get the y. Right? I take the x, I multiply it by the constant of proportionality, I get the y. And so this is an equation that represents the situation. More often you'll see it reversed, where the y is on this side and the x is on this side, and it has a coefficient. So more often you'll see that written y equals 3/2 times x like that. But this is the same thing. This is just a kind of a simpler, mathier way to write the same equation. It's also fine if instead of y and x, you write the equation with, say, time is t and heartbeats is h. So I could also write, the number of heartbeats is equal to 3/2 times the time, or s for second, or something like that. So any of these are okay, but what you want to do is just find some way to represent the x times the constant proportionality is the y. So this is a 4th way to talk about this situation, or this situation. Because if I take this and I'm like, okay, well, if x is 1, then, well, we can't do 1.5 heartbeats. If x is 2, then x times 3.5 gives me the y. So it's just another way to write the same situation. All right? Let me do a non-example here before you move on. So here's another one we've looked at, this taxi ride. A taxi ride costs $2 to start, then 50 cents per mile to ride. You can look at the graph here, I think, and the table here and tell this is not a proportional relationship because of this. And when it's not a proportional relationship, you cannot do what I just did before. You can't say the x times something gives you the cost. Because if I look at each possible thing, like here I have to do 1 times 250 gets 250. But then 2 times 150 would get me 3. 3 times, I don't even know, it's going to be something really small. 3 times, like, I think it's going to be like 116 would get me that. And then 4 times 1 is 4. And so I don't have a constant of proportionality. So I can't say no matter what the x is, you just multiply it by something, and that gives you the y. I can't do it. It's not possible. And so I can't represent it with an equation like this. You can represent it with an equation, but not one that shows a proportional relationship like this. So I'll say not possible like this, because there's no COP, constant of proportionality. Okay, open your math notebook. Let's do one together. Let's go back to Anthony and his running or swimming or whatever he's doing here. So this one we've done before too. So verbally, we would say this is Anthony runs 200 meters each minute. Actually, go ahead and pause and write all these 3 representations down. And then unpause once you've got the situation in mind. And we'll do the equation together. Okay. So we got Anthony runs 200 meters each minute. That's how we talk about it. If we write it in a table, 0 minutes. 0 meters, 1 minute, 200 meters, 2 minutes, 400 meters, and so on. And then in the graph, I've got the same thing. 1 minute, 200 meters, 2 minutes, 400 meters, and so on. So what I want to do is write an equation for the situation that is basically, I want to say y equals something times the x. I can multiply the minutes by something to get the y, since it's proportional. If it's not proportional, you can't do that. So here, I know, we found the constant of proportionality for here is 200. So in every situation here, the x times 200 gives you the y. 1 times 200 is 200, 2 times 200 is 400, 3 times 200 is 600. So no matter what I do, I can take the x, multiply it by 200, and get the y. Or if you want to use, say, t and d, so you remember what they are, I can say I take the t, multiply it by 200, and I get the d. In any case, I just have to multiply one variable by 200 to get the other. Now again, you're usually going to see this written a little differently. You're usually going to see it written, instead of x times 200 equals y, you'll see it written as y equals 200 times x. For whatever reason, that's the more formal math way to write it. Or d equals 200 times t. So you'll usually see it that way, but they're all the same. This is just 4 ways to write the same thing. So hopefully that doesn't look too complicated to you. So that's it. In a proportional relationship, you can always write y equals something times x. Whatever the y is, you just multiply the x by the constant of proportionality, and you get the y. Okay? Turn to your next page, and let's do a non-example, so you never forget that not always is this possible. So here's another example we've seen before. In this one, go ahead and pause and write these down. So in this one, we didn't know what the x and the y were. So sometimes you don't know. And you can just make something up. You can just do like time and laps or whatever you want, something like that. Or time and dollars. I don't know. It can help sometimes to make up a situation. But in either case, so here, when you look at how this works, 2 quantities, x and y, whatever they are, related in the following way. Y starts at 1. Then each time x goes up by 1, y goes up by 2. X goes up by 1, y goes up by 2. And this was one of those easy to mistake for a proportional relationship because it has such a nice clean pattern that it's easy to assume it's a proportional relationship, but it isn't. Those nice clean patterns result in a straight line, but they do not result in a straight line that goes through 0, 0. That's the only thing. So if I start looking at my table and trying to figure out, well, what's my constant of proportionality, I won't have one because here I would have to do 1 times 3 is 3, 2 times 2.5 is 5, 3 times 2 1/3 is 7, and I just don't. There's no way for me to say y equals something times x. I can't just say times 3 or times 2.5. I can't do that. So it's not possible in this form. There is an equation you can write for it, but you can't write it in the proportional form. So we're just not going to worry about it for the time being. Okay? And that's it. So that is one last way to represent a proportional relationship. So now we've talked through 4 different ways to represent it. Verbal, table, graph, equation. So lots of ways to think about these situations, lots of ways to represent the same thing. That was a lot pretty quick. If you thought that was tough or you're going to need help before you go to the you-dos when you get here tomorrow, please go back and watch some of these examples again. Once you feel like you're going to come to class with a really good understanding of this, you're all set. See you tomorrow.